Hello, Year 12. Welcome back to Maths. I hope you had a good week. We're going to be starting a new topic today, looking at trigonometry. Now, to start off, we're going to do a bit of a recap of stuff that you've done before. We're looking at right-angled trigonometry. And so there's a few things we need to cover in order for you to do this. So we have here a triangle here, and it has a right angle as indicated by that square in the corner. And we have an angle here called theta. Now it's just a Greek letter that's often used to represent an angle. And the first thing that we need to remember is the relationship of the sides to that angle. Okay, now the first thing that the first side is the angle that is on the other side of the triangle. Okay, the one that the angle is looking out towards is called the opposite side. Okay, so the opposite side of the angle is on the other side of the triangle. It doesn't touch the angle, but it's the one that the angle looks across at. Okay, so if you think about it, if you're on one side of the street, the opposite side of the street is the other side of the street that you look across at. The next side is the adjacent side, and that's the one that's next to the angle to the side. Okay, so if a house is next door to yours on the same side of the street, it's the adjacent house. Okay, so we need to know that's the adjacent one. And then the other one that's touching the angle is called the hypotenuse. Now, the hypotenuse is always the longest side of the triangle, and it's always opposite the right angle. So the hypotenuse is there. So this angle has two sides next to it. The long one is the hypotenuse, and the other one is the adjacent. So we need to remember where those sides are relative to that angle. Now, if the angle was up at the top corner, then those would swap. So the adjacent and the opposite sides would swap in that case. So it all depends which angle you're looking from for this. Now, there are three ratios in trigonometry, sine, cos, and tan, that have a relationship with these sides here. And we remember what the relationship is by this acronym SOHCAHTOA, which you may be familiar with. So what this does is it creates an equation. The sine of an angle is going to be equal the ratio of the opposite and the hypotenuse. So let's write these equations out. So sine of an angle equals the opposite divided by the hypotenuse. Okay, so always means sine angle, and then it's opposite on the top and hypotenuse on the bottom, and with an equal sign in the middle. Don't forget that we're setting up an equation here. Okay, likewise, cos theta equals, and then it's AH, meaning adjacent over hypotenuse. Adjacent over hypotenuse. So for cos theta, that is what the ratio is. And then for tan theta, okay, OA means opposite over adjacent. Okay, so we remember it's always the trigonometric ratio, so sine theta equals, and then depending on the letters, it's always the first letter is on top and the second letter is on the bottom. So for opposite over hypotenuse, etc. So that's how we remember those relationships. Okay, now use your calculator to find the size of an angle theta correct to the nearest minute. Okay, so what we need to do here is remember how we can use our calculator to work these ones out. Now here we're all trying to find an angle. So what we need to do is use inverse trigonometric ratios to find out these angles. So it's kind of like when you do an equation and you want to move something to the other side of the equation, you've got to do the opposite operation. So if you had, say, 3 times x, and you wanted to just find out what x is, we'd have to divide both sides by 3. Okay, in the same way, the opposite operation of sine, cos, and tan is their inverse operation, which we show with a little -1 as such. So this equation here would become theta equals cos inverse, and then 8 over 13 as such. So if you want to move the cos across, you have to make it the inverse, which we show with that little -1 in the top like that. So in our calculator, we go shift cos and then 8 over 13, and that will give us our answer. Okay, so make sure you go shift and then cos to get the inverse cos, and then that will give you your answer in decimal points. Okay, but this question says the nearest minute, so to convert from a decimal to minutes, we can click this one here, which is it has degrees and then the multiple dashes. So just above the ENG and just across from the HYP, we click that and it becomes 52 degrees and 1 minute. Now, remember when we're rounding minutes, okay, we only have 60 seconds in a minute. So if we have 30 and above seconds, we round up. And if we have less than 30, then we round down. So rather than 50, when we're dealing with minutes, there's only 60 there. So rounding up starts at 30. Okay, so, and that's a 1 there, sorry, 1 minute. Let's do B here quickly. So we're going to go tan. Sorry, we need to find out what theta is. So it's going to be inverse tan, and then 15 over 3, 15.3 over. So we're going to go shift tan fraction 15.3 over 11.2, and then press the arrow and close bracket, and that will give us our answer in decimals, and then we press the degrees button again to convert it to minutes. So this time we've got 53 degrees, but because we have 41.63 seconds, we're going to round up our minutes. So it's going to become 48 minutes because we needed to round up as such. Okay, so I hope you get the idea of how we find that in the calculator. We've got to move the cos across, do our fraction, and then round to the nearest minute accordingly. Okay, we're just going to do a few of these, just a couple of these as a bit of practice. So in these questions, we need to find the size of the angle for each of these triangles to the nearest minute. Now, what we're first going to do is we look at the angle. Okay, so it's in that bottom left corner for A, and we're going to think what relationship do those sides have. So because we have the one on the other side, it's going to be the opposite, and we've got the hypotenuse as well. So we've got to think which ratio we're going to use if we've got the opposite and the hypotenuse. So katoa, which one contains the opposite and the hypotenuse? And the answer is our sine one, so does. So for A, the first thing that we do is we just write our equation out. Sine theta is going to equal the opposite side, which is 5, over the hypotenuse, which is 8. Okay, and now we have an equation. We can solve for theta to find that angle. So move the sign across. Theta equals inverse sine 5 over 8. So inverse sine, shift sine, and then 5 over 8. Press equals, and again, it's to the nearest minute, so we convert it to minutes. We've got 55 seconds. It's going to round up to 41 minutes. So it equals 38 degrees and 41 minutes as such. Okay, for B, we've got to think which ratio we have. So first we look at the angle. We think we've got the opposite and we have the adjacent. So if we have opposite and adjacent, we're going to choose tan. So it becomes tan theta equals opposite, which is 5.3, over adjacent, which is 11.7. And then rearrange, so it becomes inverse tan 5.3 over 11.7. So shift tan 5.3 over 11.7 will give us our answer. Convert it to minutes. We've got 24 degrees and 22 minutes for our answer there. Okay, so set up the equation first. Choose the right trigonometric ratio, whether it's sine, cos, or tan, and then rearrange to find out whatever you're missing. In this case, we're trying to find the angle, so we have to do the inverse trigonometric ratio. Okay, we're just going to do one of these to finish up. So in these questions, we have to find a side. So we are given an angle, we're given another side, and we're missing a side, which is different to this one where we had two sides and we're missing an angle. So the first step is just the same though. We've got to look at where is the angle and where are the sides that we're concerned with in relation to that angle here. So firstly, we've got an angle at the bottom left. We have the opposite side and we have the hypotenuse. So we're going to use sine. So it becomes sine 48 degrees and 23 minutes. Okay, we can put those in brackets just so we understand that's all part of in the sine. And then goes equals opposite, which is x, over hypotenuse, which is 33. So we have our equation, and now we need to rearrange this to find our unknown. We don't need to find the angle, we already have that. We're going to get x on its own. So to get x on its own, we need to times both sides by 33, and that will give us x. So it's going to be 33 times sine 48 degrees 23 minutes equals our unknown, which is x. Okay, and now we can put that in our calculator to find out what x is, but we just need to be careful that we do it properly. So it's going to be 33 times, and then just normal sine. So we're not doing shift sine because we're not moving the sine across, just doing normal sine. Okay, and then we need to write 48, and to put the degrees in, we just press the degrees button, and then 23 minutes, and we just press the degrees button again. So whenever you need to put degrees and minutes, or maybe degrees, minutes, and seconds, you just push the degrees button, so you get this little box that's to the right of that number, which indicates to the calculator that you're dealing with minutes and degrees. And then we need a close bracket. Okay, so close that bracket off, and we can press equals, and we get our answer here. Now it says correct to 1 decimal place. So then x is going to equal 24.7, and that will give us our answer here. So this time we have the side length. Okay, we're not trying to find an angle, so we don't measure it in degrees and minutes. We're finding a side, so we measure in decimal places. And it's going to be in meters as well, because the other side was in meters as well. Okay, so I hope we remember all of these. Good luck with the questions. So remember SOHCAHTOA, set up the equation, and then rearrange to find your unknown. Make sure that we're using our calculators correctly, okay? So we know when to use shift sign and when not to use shift sign, and that we're doing degrees and minutes when appropriate. Okay, I'll see you in the next video. Good luck with that today.